So this is what I do during lunch break. This is what I do. All right, your ACT stuff. Let's see, what do we got here? We have a graph. It's about Marisha, blah, blah. She sells handcrafted picture frames in two sizes, small and large. It takes her we just did this not too long ago. It takes her 2 hours to make a small frame and 3 hours to make a large frame. The shaded triangular region shows below is a graph of a system of inequalities representing the weekly constraints Marisha has of making the frames. For making and selling a profit frames and L of small frames S and large frames L, she makes a profit of 30x plus 70L. Let's see, the weekly constraint represented by the horizontal line segment containing 9.2 means that each week Marissa makes, this was S, this was L, she makes 9 small frames. And that is a minimum. That's the bottom of the graph. She only makes 2 large. That point right there is 9 small. About lost my voice. 2 large. So 9 small. Oops, sorry. I got this backwards. Small frames is going right. That's a maximum. Large is going up. That's the minimum. I almost missed that question. I'm glad I hesitated there. Because large frames is going up. Like up here, she makes a maximum of 8. She's going to make a minimum of 2. For every hour that Marisha spends making frames in the second week of December each year, she donates $3 from that week's profit to a local charity. This year, she made 4 large frames and 2 small frames in that week, which of the following is closest to the percent of that week's profit Marcia donated to charity. All right, it takes her 2 hours to make a small frame. She made 2 small frames. 2 smalls, 2 hours is 4 hours. She made 4 large frames, 3 hours. So 3 large at 4 hours is 12 hours. So 16 hours total. And it says that she donates $3 from that week's profit. For every hour she spends working, she donates 3 hours. So 16 times 3 is $48. And let's see how much money she made. We have this equation up here. She gets $30 per small, and she made 2 of them. And she gets 70 per large, and she made 4 of them. So that's 60 plus 280, $340. So she's giving away 48 of her $340. You just need to convert that to a percentage. It's probably around 14 or 16%. I got 14.1%. So choice C, unless I just did division. What is the maximum profit Marcia can earn from the picture frame she makes in 1 week? That either happens here or here. So one of the two. So here's where she makes no small frames. So if we use 0.8, she's 30 times a 0 plus 70 times an 8, which is a good chunk of money. I mean, it's $560. But it took her, what, 24 hours to do it? Yeah, she's not making much money per hour. If she does it here, 9.2, she gets 30 for every 9, and then she gets 70 for every large. So that's going to be 270 plus 140. It's not as much money. It's $410. 560. We did this lesson. This is where the maximums or minimums happen at the vertices. Let's see. I believe this was just done for y'all today or the day before, the determinant of a matrix, and they give you the formula. It's AD minus CB. That diagonal, take away that diagonal. What must the value of x be for this matrix to have a determinant of negative 16? So x times x, take away x times 8, must be negative 16. That's the deal. That's the deal. That's x squared minus 8x is negative 16. X squared minus 8x plus 16 is 0. We're one-siding it, setting things equal to 0. Let's see, factors of x squared are x and x. Factors of 16 are 4 and 4. To be add up to a negative 8, they're both negative 4s. So my x value is 4. Ta-da! The other thing you could do, and I mean you can check it, you can play around on a calculator. I don't know if it's any quicker or not. It just depends on if a kid can factor. But everywhere I see an x, I can put in a positive 4, and then I can just go through the process. Second matrix math, determinant, second matrix A, 48. That's weird. Must have a typo. I think that I made a typo here. I think I put negative 8. It's supposed to be positive 8. 8. Yeah, there we go. See, checks out. A formula for finding the value of $A of P dollars invested at I% interest compounded annually for N years is A is the principal times 1 plus 0.01 I raised to the N. So that's an exponential growth formula. Which of the following is an expression for P in terms of I, N, and A? What they're doing is they're saying solve for P. This is a ridiculously easy question to be this far in on the ACT. Just solve it for P. That's all you do. And I'm going to write it down so I can show you the understood symbolism between P and that parentheses. You see that multiplication symbol? The opposite of multiplication has always been division, and it always will. If you divide one side by something, you've got to divide the other side by something. And you know, 80% of all students would miss this. But this is what I'm looking for, which looks like choice H. Nope, 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 nope. Okay, H was a decent distractor. You had to pay attention where they had that exponent. 55, if x and y are real numbers such that x is greater than 1 and y is less than negative 1, which of the following inequalities must be true? This is an ACT strategy. Make up a number for x and y. Never, ever, 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 ever use 0, 1, or 2. Don't do it. So I'm going to let x be something big like 5, and I'm going to let y be something else like 6. All right, and I'm just going to go through the process. A would be 5 over 6. I'm plugging in greater than 1. That's false. It says must be true. B is the absolute value of x, which is 5 squared, greater than the absolute value of y, which I made 6 squared. That's 25 greater than 36. That's false. All right. Moving on to C. I'd have 6 over 3 minus 5 greater than, oh, Milbrath. Well, I had to be negative 6. I didn't catch that little disclaimer there. That's still false. That's still false because that makes it positive. It's a big deal here, though. I got lucky not paying attention. Notice it says y has to be less than negative 1. I had to fix that. I made it negative 6. So 6 thirds minus 5 is supposed to be more than negative 6. Sorry, x was 5. 5 thirds minus 5 has to be more than negative 6 thirds minus 5. And this is definitely true. I mean, if you got to push buttons in a calculator or whatever, so be it. But this is definitely true because this side is negative 7, and this is a little bit less. I mean, this is 5 thirds minus 5, which is 10 thirds. That is true. Now, I'm just going to go through the rest of these and see if they hold. So I'm looking at D. D would be a 5 squared plus 1 greater than, ruh-roh, negative 6 squared plus 1. This ends up being 26 greater than 37. Oh, that's false. We want true, don't we? And then we have E. They have a funny little exponent there. That's x to the negative second greater than y to the negative second, which is 1 over x squared greater than 1 over y squared. So this would be 1 over 5 squared greater than 1 over negative 6 squared. And 1/25 is bigger than 1/36. Ooh, we have a true statement. We do. We have a true statement. That sucks. It's between C and E. So what do? We make up new numbers. That's what we do. We make up new numbers. And again, it's a strategy on ACT. Make up new numbers. So this time we'll let x be 7, and we'll let y be it's the squaring that makes me think that this one's going to win. Or if you let y be negative 3, or y be negative 10. I think it's pretty easy to come up with an idea that makes this one fall. If I let x be 7 and y be negative 3, I'd have 1 over 7 squared greater than 1 over negative 3 squared, which is 1/49th greater than 1/9, which is false. I was just trying to think of numbers that would make this one fail. So this one does eventually fail. C is going to win out. C is always going to win out. So there's your ACT stuff. Hope you enjoyed it. And I hope you learned to plug in numbers and think. I'm not a huge fan of problems like that.